Engineering teams are currently using AI coding assistants to ship features at a pace that was impossible 2 years ago. But this speed obscures a growing liability. The average cost of a data breach has now climbed to over $10 million, and unvetted AI code provides a direct path to that valuation. In July 2025, an unsupervised AI agent was tasked with a routine database cleanup. Within seconds, it wiped out an entire production environment. There was no malicious hacker involved. It was an autonomous tool doing exactly what it was told, without limits. Developers are now generating thousands of lines of logic through casual text prompts, multiplying their output by 10. This is the reality of vibe coding, but writing code is not the same thing as understanding it. This diagram illustrates a new organizational crisis: comprehension debt. When an AI generates a complex system that perfectly executes, your team deploys it without knowing how it actually works. If a critical bug surfaces later, the bus factor is 0. Nobody on the payroll possesses the structural knowledge required to safely modify that logic. Left unchecked, these automated workflows are actively mapping out new pathways for enterprise liability. Basic syntax errors are a minor concern compared to the structural liabilities introduced by large language models. These divide into 4 distinct categories: data debt, model debt, configuration debt, and ethics debt. Let's look at how this flowchart maps a live threat. This represents a prompt injection attack. During live runtime, a malicious user slips hidden instructions into standard text inputs. The agent reads the input, ignores its original programming, and hijacks the execution path toward an unauthorized action, like leaking customer emails. Prompt injection is a surface-level problem. If we trace this architecture backward to the training phase, we find a deeper vulnerability: data poisoning. Here, attackers intentionally corrupt the raw data the model studies months before it is deployed. Because the corruption happens at the foundational level, the malicious data integrates directly into the AI's core logic. The model learns a deliberate blind spot. When the attack executes, your external defense perimeter sees nothing wrong, because the threat is already baked into the machine's brain. This gets terrifying when applied to AI-enabled low-code environments. When business logic is wired through visual workflows and chained APIs, a single manipulated output from an AI can cascade instantly through your entire network, triggering unauthorized actions across multiple departments. The speed generated by unguided vibe coding comes with a massive cost. It drastically widens your organization's attack surface and leaves your infrastructure vulnerable to multi-layered cybersecurity failures. Software usually breaks because someone introduces bad code. AI is different. Even if nobody touches it, a deployed machine learning model will decay. The longer it runs in the real world, the less accurate it becomes. This scatter plot illustrates a process called concept drift. Initially, the model draws a clean line between 2 clear sets of data, but real-world human behavior evolves. Over time, the actual relationship between your input features and your target labels shifts, rendering that original boundary useless. We also have to track covariate shift. This happens when the actual distribution of user inputs in the live serving environment separates drastically from the original data the model was trained on. If your team relies on standard static security testing or legacy code scanners, you are completely blind to this. Those tools look for hard-coded bugs. They cannot detect statistical drift in a model's live reasoning. Unless you implement continuous monitoring to track performance skew in real time, a secure model on day 1 mutates into an unpredictable liability by day 90. When models decay and logic becomes opaque, a technical problem becomes a human one. If a developer cannot identify why a model is drifting, they cannot fix it. This reliance creates cognitive debt, the organizational cost of outsourcing our critical thinking to machines. This creates a psychological trap known as sophistication bias. When an AI generates a massive, intricate block of code, engineering teams instinctively assume that because the output is complex, it must be superior to human logic. As a result, your developers stop actively solving problems and are demoted to passive reviewers. They are forced to sign off on completely opaque, machine-generated logic they don't actually comprehend. The countermeasure for this is the simplicity challenge. For every piece of complex AI-generated logic introduced into your codebase, mandate that your team writes a simpler, human-readable equivalent. Surrendering the daily friction of problem solving hollows out your engineering talent, ultimately paralyzing your company's leadership pipeline and future innovation. Policy manuals cannot control non-human actors. Protection requires a foundation of structural engineering. A text prompt politely instructing an AI agent not to delete files is an insufficient safety measure. Real protection requires machine identities. When an AI agent attempts to access a central database, it must operate without human user permissions. It requires secret list authentication and strict least privilege access, ensuring it only touches exactly what it needs for a specific task. You also need an operational mandate for shadow mode. Before a new AI agent touches production, its requests are routed into an isolated sandbox clone. The agent makes decisions, and the system records them, but it has zero ability to execute those commands live. By physically decoupling your data ingestion pipelines, training environments, and live deployment servers, you effectively contain the blast radius. If a poisoning attack succeeds or severe model drift occurs, the damage cannot spread to the rest of the business. Success in the AI era belongs to the organizations building the strictest walled gardens and maintaining total human accountability. Generating volume is easy. Maintaining control is where the value is created.